Assalamualaikum warahmatullahi wabarakatuh. My name is Safi Izzuddin bin Muhammad Nazri and my matric ID is MA1815. So today I will present about chapter 1 introduction for our last lab. Okay. The investigation of flow pattern over immense bodies and boundary layers. First one is the external flow. Past objects encompass a variety of fluid mechanics phenomena. The character of the flow field depends on the shape of the object. Even the simplest shaped object like a sphere produce rather complex flows. When a fluid flows through an object, the object will experience a resistant force that prevents the object from moving to its direction. It consists of horizontal and vertical forces. While the horizontal force is the drag force, the vertical force is the lift force which is perpendicular to the flow of direction. In Bernoulli's theorem, when decrease in velocity, pressure will increase. In Bernoulli's theorem, when decrease in velocity, pressure will increase.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Akil bin Ahmad and my metro ID is MA18186. So I will explain a little bit more about the theory. First is for the airfoil. Airfoils are produced with the upper face being longer than the bottom surface. As a result, when air molecules are divided by the airfoil's leading edge, they must travel a greater distance over the upper surface than they must travel along the lower surface. In order for the air molecules flowing along the upper surface to converge at the trailing edge at the same moment, the molecules flowing down the bottom surface must be going quicker. This figure is the airflow about an airfoil according to the flow turning theory. Next, for lift equation, it is L equal to 1 over 2 rho V squared SCL, while the drag equation is D equal to 1 over 2 rho V squared times by ACD, where L is the lifting force, rho is the density of the air, V is the relative velocity of the airflow, S is the area of the airfoil as viewed from an overhead perspective, and CL is the lift coefficient, while for drag equation, D is a drag force, rho is the density of the air, V is the velocity of the air, A is a reference area, and CD is the drag coefficient. Next is a boundary layer. The boundary layer is a layer of fluid immediately adjacent to a bounding surface where the effects of viscosity are significant. Laminar and turbulent boundary layer flows are the two forms of boundary layer flow. The turbulent boundary layer has swirl, whereas the laminar boundary layer is quite smooth. Laminar flow produce less skin friction drag than turbulent flow, although it is less stable. The figure below shows is the laminar and turbulence of boundary layer. I think that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noatirah binti Abu Bakar. My matric ID is MA18188. For this experiment, I will present chapter 3, method and procedure. This experiment consists of two experiments, which is experiment 1, the flow patterns of symmetric aerofoil at different angle of attack. As we can see, figure 3.1 is the experiment setup for this experiment, and figure 3.2 the angle of attack needed. This is the procedure for experiment 1. Firstly, the experiment was set up as in figure 3.1. The aerofoil model was attached and screwed to the airflow bench. Firstly, the experiment was started at 0° angle of attack as in figure 3.2. The switch was turned on and the radial fan was allowed to move. The radial fan speed controller was adjusted at an initial speed of 12. The readings were recorded and tabulated. The smoke controller was pressed to emit smoke into the flow to view the flow of the air on the aerofoil. The picture of the flow of the aerofoil was taken. Then the radial fan speed controller was increased by 1 till speed of 19. The experiment was repeated from step 5 to 8 for 30-degree and 45-degree angle of attack as in figure 3.2. Next, we have the experiment 2, which is flow over flat plate. This is figure 3.3, which is the experiment setup for experiment 2. And we have figure 3.4, which is the surface of the flat plate. We have two different surfaces, which is rough and smooth plate. This is the procedure for experiment 2. The experiment was set up as shown in figure 3.3. The smooth surface flat plate was inserted into the airflow bench. The first distance was set up as 0 and the following distance was taken. The pitot tube was connected to the vernier calipers. The pitot tube was touched to the surface of the flat plate as the first data. Next, the radial fan was turned on and the data was recorded and tabulated. Then the distance of the plate was taken from 0 mm, increased by 20 mm to 140 mm, while the pitot distance from the surface of the flat plate was taken from 4 mm to 32 mm. This experiment was repeated from step 5 to 7 for the rough surface as shown in figure 3.4. That's all from me. Thank you.
Assalamualaikum. And now I will proceed for the next chapter, which is the result and discussion. My name is Muhammad Nur Sufian Besudin with ID MA18263, and I will present for the experiment 1 flow pattern of symmetric aerofoil at different angle of attack. As you can see, this is the formula used to determine the drag force and lift force flow over immersed body. And we get the result for the drag force and lift force. For example, for the angle of attack 0 degree, for the fan speed 12, we got the head is 133.5 and calculate drag force 0.000623, lift force 0.0000887. While for the angle of attack 30 degree, for the fan speed 12, we got the head is 133. Calculate drag force is 0.001797 and lift force 0.00259. For the angle of attack 45 degree, for the fan speed 12, we got the head is 132.5, while the calculated force 0.02543, lift force 0.00362. And this is the graph for the drag force against the fan speed. And this is the graph for lift force against the fan speed. So the graph of drag and lift force versus fan speed show that as the fan speed increase, so does the drag and lift force. The higher the drag and lift force, the greater the angle of attack. The drag force is related to the velocity of the object moving through the fluid. Lift force is probably related to the square of the flow speed and proportional to the density of the air. And lastly, this is the streamline of the airflow. As you can see, if the angle of attack is different, then the stagnation point and separation point is different. So that's all for the experiment 1. Thank you.
Assalamualaikum. My name is Amirul Ashraf bin Abdul Rahman. Metric number MA18257. I will continue on experiment 2, flow over flat plate or boundary layer. So this experiment is divided into two parts. The first one is by using the smooth surface flat plate. So the table shown are the data obtained from the experiment. The data from the head measured table will be used to calculate the velocity v by using the formula square root of 2g times delta h. And from the value of velocity that we have calculated, we can compute the Reynolds number by using the formula rho vl over mu. So from the data obtained from the experiment for measured head loss and the calculated value of velocity and Reynolds number, we can develop graphs. The first one is the head against boundary layer for smooth plate in difference plate distance. So from the graph shown, if the boundary layer thickness increase, the height recorded will be decreased. This is due to the increase in boundary layer thickness will cause the pressure in fluid flows from the pitot tube to manometer become higher, and this will further push the fluid in the manometer, thus lowering the height in manometer. Second graph is the velocity against boundary layer for smooth surface. So based on the graph, if the boundary layer thickness increases, the velocity of the fluid increases as well. By comparing from the aspect of difference in distance of the plate or the length of the exposed plate, a smaller distance produces lower velocity. When the length of the plate is short, the boundary layer will be thin, so the velocity will be lower, and the thickness of the boundary layer increases with the length of the plate where the fluid flows by. The third graph is the Reynolds number against boundary layer for smooth surface. So computing the Reynolds number for every set of data, we found that the thicker the boundary layer, the Reynolds number increase due to the increase in velocity. Reading the data according to the thickness of boundary layer, we can only observe a slight increase in Reynolds number with the increasing boundary layer thickness. The range of the distance of plate X is enough to show that it is a laminar flow, which is below than 2000. So we move to the second part of the experiment, where the experiment procedure is repeated for rough surface flat plate. The graph shown is developed from the data obtained from the experiment for head measured by using the rough surface flat plate. So from the graph above, if the boundary layer thickness increases, the height recorded will decrease. This is due to the increase in boundary layer thickness will cause the pressure in fluid flows from the pitot tube to manometer become higher, and this will further push the fluid in the manometer, thus lowering the height in manometer. Second graph is the velocity against boundary layer for rough surface. Based on the graph, if the boundary layer thickness increase, the velocity of the fluid will increase as well. By comparing from the aspect of difference in the distance of the plate or the length of the exposed plate, we can say that a smaller distance produces lower velocity. The third graph is the Reynolds number against boundary layer for rough surface. So from the graph, we can observe a slight increase in Reynolds number with the increasing boundary layer thickness, and the range of the distance of plate for the rough surface flat plate also enough to show that it is a laminar flow.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Salahuddin Singh, and metric number MA242. And in this chapter 5, I will present about the conclusion of lab 2. So ultimately, we were able to complete this experiment virtually. In this experiment, we finished designing a full fluid flow measurement instrument and measure the drag lift forces given to symmetrical airfoil at various angles of attack. The velocity distribution for plate is also established, as well as the speed of the flowing fluid. The Reynolds numbers and the roughness of the plate are all elements that impact the boundary layer on the Reynolds number will rise as the speed of the flowing fluid rises.